We welcome Dr. Gautam T. Makwana. Dr. Gautam Makwana will be our next speaker. Dr. Makwana is an associate professor associated with Gujarat Technological University School of Engineering, Ahmedabad. He started his career of teaching from SNPIT as a teaching assistant and served to Sakarchand College of Engineering and Technology for more than 19 years. He pursued his PhD in Electronics and Communication from DAIICT, Dhirubhai Ambani, in 2016. He has pursued his master's in telecommunication and BE Electronics from SNPIT Surat. He has published 3 patents and he has also published 4 design patents. And he has been working in SSIP cell for the Sakarchand College of Engineering. His research area includes IoT, 5G, 6G technologies, machine learning, deep learning, wireless communication, antenna engineering, etc. And he'll be presenting on challenges in IoT applications. So thank you very much, sir, for joining us.
Yes,
you may start your
thank
presentation,
you,
sir.
Dr. Tilak. My slide is showing to you.
Can you speak?
Am I audible? Hello. Yes, am I audible?
Sir, I guess your voice is not coming.
Am I audible? Am I audible? Okay. First of all, very sorry to all the participants for the delay in my network issue and the sharing of my presentation. And I am very grateful to the Sitaraman Nananji Patel Institute of Technology, Bardori, to inviting me in the ATAL FDP, Internet of Things and its applications. My topic is the challenges in the IoT applications. In this case, I will discuss the IoT concept, various IoT architectures, IoT application challenges, and IoT use cases and the future directions. In the IoT use cases, I will discuss the 2 mainly use cases regarding the IoT development of the systems, and what are the challenges they face, and what are the possible solutions to solve the IoT solution for the various sectors. Now, as you know, the Internet of Things is one of the most emerging topic in the world, and from this IoT concept, the number of the things are connected. So here it is the any devices. So there are the many kind of the devices that can be connected in the internet IoT system, and anybody, so anyone, either it is a human being or non-human being object, can be connected into the IoT, and anywhere. So from the any location of the world where the the object or the system can be connected on the internet system, and any to make the digital transformation of their process into the IoT system, to make the more efficient process or business for the maximum outcome of the processing and any networks. So in this case, in the internet point of view, many devices like a computer system and the IoT non-computers devices or non-computer devices are connected. So here many nets of different protocol can be connected in the internet. Here, of the internet point of view, like a TCP/IP protocol, infrastructure to make the system to make
Sir,
the internet settings
hello,
system.
sir.
The one of the person is varying because
Hello, sir. Sir,
there are so because of the this concept about the IoT and because of the any device, anywhere, anytime, any network, and any structure requirement. Yes, yes. Hello. हाँ बोलो बोलो. Hello.
hello.
Am I audible? Hello,
Sir,
बोलो
you are
बोलो.
audible, but your slide is not changing. It's moving. Slide is not
It is on the
changing.
first slide only.
This is only first slide.
It is on the only first slide. Yeah. I'm changing now.
Yes,
Okay, no issue.
yes.
Slide number 3 is right now actually.
No, right now only first slide.
It is visible?
Is it visible? But that is not moving from one slide to another slide.
I think I shared the slide to you. Please check your email. So then you can share.
Okay, sir. You send me. Hello. You send me
Yeah.
your slide. I will present from here.
I sent.
Okay.
I just sent this something.
Okay. You send your slide to me. Okay. ચાલો હવે આને હું અને ડાઉનલોડ કરી દઉં. હા.
Am I audible now?
Sir, your voice is not clear now, but I am sharing slide right now. કરું છું. Right? ડાઉનલોડ કરીને મૂકી
Now am I audible? Hello.
Yes, sir, you are audible, and I have shared your slide.
Yeah. So
Yeah.
this is just my introduction about the first slide, and please go to the second slide.
देखा मैंने? हाँ, यहाँ. हाँ, बराबर.
Can you go to the second slide?
Is it okay now? Hello, sir.
Hello. Go to the second slide, please.
Second slide. This is second slide तो है.
No, it is not coming here. Second slide. Only showing the first slide. Hi now. Okay, yeah. Yeah. Okay. So this is agenda of this presentation is the IoT concept, IoT architecture, IoT application, IoT challenges, IoT use cases, and the future direction regarding the IoT point of views. So please go to the second slide, because now in a next yes. Now in the IoT application or IoT solution, there are the requirement of the different kind of the part, that is any devices. Here the any kind of the object which is required to connect to make the process simple and the effective in the part of the this IoT system, anywhere from the any location, anytime, any business, any network, and any infrastructure, and anybody. So this is the need of the making the any conventional process to convert into the digital system to make the process efficient. That is the need of the IoT solutions. Now, because of this requirement, there are the many challenges come in the for the IoT solutions. So there are the many devices are required to connect and anytime. So this system to be reliable and seamless communication between the any object or any machines. So in this case, if you just see the slide that contain the number of the connected devices, number of the devices per person, and the world population. So day by day, this number are increasing the number of the connected devices. It is up to the 7544 billions that are the right now the number of the devices are connected. As the same way, yeah, there is the one. Make the slide full screen, please. So here the many devices are connected to make the IoT systems. Now to design the any IoT system, we require the different kind of the component, and there are the 7 pillars that require for the IoT system development. The first one is the sensing and the actuation, identification of the different kind of the component. There are different kind of the communication technology from the object to the gateway, from the among the gateway to the some internet backhaul networks, and the cloud platform. So there are the different level of the communication are required to make the system and to achieve the concept about the IoT requirement. Then it is the computations, where the many the from the various sources, from the various location, data is captured, and to make the decision based on the data captures, we require the some computation power at the different stage of the IoT architectures. And based on this computation, the end users, like the any citizen or any business model that required. Can you go back to the third slide? Go back. In this slide, there are the different architectures are possible. So here it is having the physical layer, network layer, and the application layers. So generally, in the layman language, there are the three layers is defined. There is the physical layer, network layer, and the application layer. In the function of the physical layer is the sensing the various parameter, and the actuating is based on the action. We need some object to make the system possible, and identification and the power supply. And there are the many protocol that are in the physical layer. That is the Wi-Fi, Z-Wave, NFC, RFID, and the wireless PAN. And there are the different objects that can the machine or maybe object. And the second layer is the network layer. That is for the connectivity of the object with the end users. There are the different protocol IP version 6, RPL 6, low PAN, and UMTS. And for the application layer, main is the monitoring, alert, controlling, optimizing, and management. So there we are the different kind of the protocol that require, that is the COD, MQTT, AMQP, XMPP, and the DDS. So this is a basic architectures of the IoT, where the application, smart home, smart healthcare, smart city, smart agriculture, smart traffic, and the smart industry. So this is the basic architecture of the main point of the IoT point of view, where the main design the application that is behave as a smartness. So there is and please go to the your next slide, sir. Next slide. Hello. Hello.
Sir. This is
Next
fourth
slide,
number
please.
slide. Fourth number slide.
Yeah. Go to the next slide.
Next. This one?
No, it is slide number 4 actually.
Slide number 4. This one. This one?
No, slide number 5 now.
5. This one?
Yeah.
Okay.
Okay, so as discussed in the previous slide, there are the three layers: physical, network, and the application layer. Now, to achieve the this three layer architecture, so it is divided into the 7 layer. That is the physical device and the controller. The in the physical device and the controller, it is a different kind of the object or things, and we require some computing power or some memory power. So there is maybe it is a edge computing, and the connectivity. So there are the connectivity of the object with the upper layer. There is a access technology with the help of the Wi-Fi or Zigbee or LTE. And the next is the edge computing that depending upon the data is captures. This edge computing layers are giving the idea about the what kind of the data can be computing, and how the data can be processed further, and how it can be transmitted to the last of the cloud computing. And based on this computing edge computing layer, there are the different kind of the protocol, different kind of the interfaces required between the physical layer and the application layer. And the next layer is the data accumulation. So that basic function of the data accumulation is the to give the to store the data in the different way, because the in the different object the data type and the format of the data type is different. So this main function of the data accumulation is the to store the data in the different way that can be accessed by the many users. And layer number 5 is the data abstractions that can be from the data storage. What kind of the data is important and what kind of the data is not important are separated out, and based on the that things data is giving to the application layer, and that application layer different reporting analytics and control can be accessed by the application layer, and the collaboration and the process that can be the different business can be contained here. Now in this three layer, so there are the different class of the device and firmware, middleware, and application software. So typically in one IoT node, there are the physical device that can be having the different kind of the object based on the applications. And the firmware will be the decided by the based on the system. That is the real-time operating system, embedded OS, operating system, and the kernel. So for the a different application, this kind of the RTOS or immediate OS are as of now, there are the different unstandard operating system, and this will create the challenge making the sustainable IoT applications. As the same way, the processor layer that contain the communications point of view, Wi-Fi and the BLE. So this is regarding the how to make the communication between the different locations or different point in the any geographical areas. Transport layer and the application layer. So here now in the internet, so this TCP/IP protocol is very popular, but the TCP/IP protocol is having the fully function. That is there is no limit about the computing power, no limit about the memory, and no limit about the power consumption. But in the case of the IoT, many object or many devices are having the constraint in the regarding the computing power, memory, and power consumption and the bandwidth utilization. So there is some kind of the new protocol is required to interface with the TCP/IP protocol stack and different object of the IoT. That kind of the new protocol is required to make the communication between the on the internet. So that kind of the protocol is the partial 6-slope pane adaptation layer that can be used between the TCP/IP concept of the internet with the IoT concept. So this kind of the interference are required between the TCP/IP protocol and the IoT. The same way, there is another kind of challenges are in the internet IoT stack is the there are the many devices are the non-IP and there are the some devices are IP. So based on the this IP devices and non-IP devices, the how it can be communicate or transmitted, because in the IP version 4 or IP version 6, there are the many the size of the header or the contain more than 1 kilobyte. But in the case of the IoT application, we require the data of the only few byte. So in this case, we have to control the data transmission on the internet protocol with the adding the removing the some part of the data format of the IP version 6 So that kind of the interference is required when you put your IoT devices on the internet, because otherwise the power consumption or memory or maybe the bandwidth of your communication protocol will be the wasted, which is not a good idea for the efficient IoT solutions. So there are, at the same way, the application layers. Now, if you just get to the internet applications, with the base main objective of the net is providing high rate and the maximum data transfer. There are the many kind of the client base application, but in the case of IoTs, we are having large data size, the processing data. We have very small processing data size, and at the same way, there are the many connected to each other. So to get this concept, we are required to develop the new. We are required to use the new protocols in the application layer. And for this case, generally we are using the HTTP protocol in the internet services, but that protocol is a very heavyweight protocol that consume the more power and require the more bandwidth. But in the case of the internet, it is preferred to use the MQTT protocol, COP protocol, XMPP, and DDS, and the web socket. So that kind of the application layer are useful and used in the IoT. But in the case of the internet services, this that protocol is not useful in the case of the IoT devices. So this is the main scenario, that how the IoT and the internet are differ, and there are the different kind of the requirement from the different region, different processing and the different private and the public requirement. So because this IoT solution are useful for the getting the some kind of the benefit to the customer, some business point of view. So their requirement is different, and the requirement of the internet is different. So for this case, there are the different kind of the network, different kind of the devices, and different kind of the security or private network are used in the internet. So as of now, there are no specific standards are utilized as in the case of the TCP/IP stack. So different people, different region are using the different kind of the protocols, a different stack in the number of the hello, in the different kind of the layers. So generally it is divided into three layers: physical layer, network layer, and the application layer. But the different applications having the different kind of the requirement, and according to that one, some protocol are, some layer are added into the any IoT kind of the requirement. So can you give me the? Can you go to the next slide?
Yes, sir. Yes, sir. Okay.
Yeah. So this is a different kind of the IoT applications. So if you just go, you know, all are the so this is a different kind of the smart application. This is a smart home, smart health, smart agriculture, infrastructure monitoring, intelligent transportations, smart cities, factory and automation, and industry 4.0, smart power, and the water grid. So if you look at the this application of the IoTs, so for one case of the, suppose the smart agricultures. So in the agriculture sector, there are the many requirement and different kind of the sensor and the actuator is required. Different kind of the region. Maybe it is for the one farm, or maybe the multiple farm, or maybe the one geographical areas. So for this case, the solution and the design of the smart agriculture is the different need of the architecture. So for this case, in the same way, suppose if you go for the smart home or maybe the smart grid. So for this case, it is a different kind of the requirement for the person to person. If you look at for the only one solution for the automation in the one home, and at the time the different kind of the system design is required. At the same way, if you just go to the controlling the power consumption of a one area, then there are the different kind of the solution or design of the IoT is possible. So there are the many kind of the such kind of the requirement for the to make the all the object of a one particular region to be connected and give the efficient use of the that object for the maximum output in the term of the yield or in term of the efficiencies of your system. So this system are having the different kind of the requirement. So this is the idea there the to make the here the devices for to integrate the all the applications. There are the many kind of the devices. That is the issue when you make the system for the number of the many thousand of the persons. So this is a case where we have the issues. The different kind of the communication protocol is used in the each every this applications. So there is some kind of the how we can connect the one IoT application with the another IoT applications. So this is the when you make the one system at the time there are the many kind of the issue that will that kind of the thing is the discuss in the my coming slide. Can you go to the your next slide, please? Hello.
Hello.
Yeah.
This one.
Yeah. Okay.
Okay.
Yeah. This one. Okay. So in this if you just look at this slide very carefully, so at the time it is giving the idea about the uh, different kind of the requirement. So here the emerging IoT application, so it is divided into the three part depending upon the requirement of the data rate: raw data rate, moderate data rate, and the high data rate. So if you just see smart farming, the smart home, and the smart retail, there the data rate in the range of the if you just see that it is a range of the up to the some kbps. In the case of the moderate data rate, so at the time it is having the more medium data rate up to the some MB rate and high data rate. So in this case, if you just see the how the internet connectivity is. So here it is the RF for the raw data rate. It is Wi-Fi, GSM, BLE, Zigbee, and the Z waves are the main communication protocol, the connectivity where we require the raw data rate and the network size. The network size for the raw data rate, it is up to the maximum up to the 1,000, and for the moderate data rate, it is less than the 10,000. And for the your high data rate, well, we require the more than 10,000 nodes in the your network size. So now, at the same way, different kind of the analysis are done at the local level and at the your distributed level in the central point of view. And the delay, that is the latency, depending upon the application. For the raw data rate application, it is the second 2 hour, or it may be the 1 day, or maybe 1 hour. And the high data rate, like the smart health, smart city, and the factory or industry 4.0, we need the delay in the millisecond to seconds. So that kind of the thing are distributed here, and the type of the data. The type of the data will be the maybe simple text file, or maybe the different video stream, depending upon the applications is required. And the computing, there are the three different way we can make the computing. One is the on the cloud computing, fog computing, and the edge computing. So depending upon the this computing is where we have to do the computing. It depends upon the size of the networks and the size of the your delay or latencies. If we require the latency more, then it is better to do the computing at the cloud level. If you require the computing at the in the term of the millisecond or second, then it is having the do the computing in the edge computing or fog computing, and the some of the computing will be done on the cloud computing. And whenever we make the size of the network very small, at the time there is no need of the edge computing or the fog computing. And when your size is more network size about the 10,000 or maybe the 1,000, at the time that we have to use the edge computing and the fog computing. So that kind of the requirement, where we can use the different kind of the computing technologies for the your different kind of the requirement of the IoT applications. In the same way, the last column will use given the what kind of the sensor use actually. So different application use the different sensors and different actuators depending upon the application of the IoTs. So in this case, if you just see, there are the different sensors, and to integrate the all this IoT application, there are the issues, because the different in this case there are the issues regarding the internet connectivity, network size, and the latency, computing, and the devices used in the IoT application. So different technology, different communication protocol having their rules and their algorithms to make the connections or make the transmission. So whenever you make the use the different communication protocol in a single, so at the time that there is the issues regarding the format and regarding the modulation techniques used in the protocol. So that kind of the issues arise when you make the different kind of the IoT applications. So can you go to the next slide? Any question at this point? Yes, next
Participants,
slide.
if you have any question, then you can write in chat box.
Please go to the next slide, Dr.
Okay. Oh. This one?
No, slide number 8.
8, yes, 8. Okay. This one?
Yeah.
Oh.
In this, you can see the what kind of the features are required in the range. This is giving the different kind of the networks used in the depending upon the range of the area communication. That is the communication range from the 10 to 150 meter. That is the short range. 150 to 1,000 meter. That is the short and medium range. And 2 to 50 kilometers medium range, and up to the 100 kilometer. That is the long range. So depending upon the communication medium, we have to identify or select the communication standards. So that is what kind of the network that can be useful to cover the communication range. So if you just go to the up to the 100 kilometer, so that is the 3G, 4G, 5G, LPWAN, WRAN, NB-IoT, satellite communication, cognitive radio, IGNU, and the Terensa. And if you just go to the short range, there is a Bluetooth, BLE, Zigbee, Thread, Z-Wave, N-Ocean, and ANT. So depending upon the communication range, we have to select the communication standard for the to access the different devices on the IoTs. And here the frequency is also given here, 2.4 gigahertz to the 900 to 18 megahertz for the short range to the long range. And the maximum data rate in the 1 to 2 Mbps, 11 to 54 Mbps, up to the 2.4 Mbps or 260 Mbps. And here there is also define the different IoT application based on the communication range. So this is not a standard way of the selection of the communication standard. But whenever you design the go for the IoT application that cover the more number of the applications or integration of the all this smart application, at the time there are the different kind of the communication protocol, and the requirement is the uh, uh, requirement is can be to be fulfilled. So here there are the different kind of the requirement. That is whenever you go for the high data rate. So high data rate at the time the meaning is the your application is very crucial. So we have to care about the we have to care about the your communication is the same range, and it is available 24 by hours. And also we have to consider the mobility of the device. Whenever you go for the moderate data rate or high data rate, or maybe the medium range communication, or rather long range communications. So whenever you go for the shorter range, at the time your maybe your devices are not mobile. So at the time we don't want to consider the protocol that can be useful for the mobile devices. But whenever you go for the longer communication range, at the time it is maybe possible that the few devices are mobile, but the few are static. So based on this, we have to select the communication standard that can be offered into the mobility of the devices. And another concept of the requirement in the different applications is the device management. Device management is the one of the critical issues. Whenever any device will be having the malfunctioning, or maybe the damage due to the some other reasons, so how the my application will be sustained. So this kind of the device management is very important, and we have to deal with the such kind of the how the my system will be the robust. So in the same way, your system should be the self-diagnose. Your system will be the self-diagnose. So in this case, whatever the any kind of the suppose in the IoT solution. So there are the two part, hardware and the software, and the third is the communications. So if my hardware will be damaged, if the any component of the my hardware in the my device will be the damaged, so that device will be the not able to make sense, giving the data to the my upper layer of the my IoT. So at the same way, if there is something happen in the software, so at the time the software will not work, then my IoT system will be collapsed. At the same way, the communication is not occur between the two device or two machine or object to the gateway. So at the time the my system will collapse. So we have to make the system that can be diagnosis based on the condition of the hardware, software, and the communications. So in this case, we have to add extra node in the my vicinity of the my requirement, where the that node will monitor the condition of the hardware, software, and the communication of the all the surrounding nodes, or all the object of the node. So this kind of if you do this kind of the adding this kind of the facilities in the IoT application, at the time the requirement of the 24-hour available IoT system, that can be possible. So this self diagnosis is one of the need to make the to achieve the concept about the IoT, where we need the 24 by available. Whenever any data will come at the time, my system should be work. So this can because if you go for the larger area, so at the time it is very difficult to change if you replace my malfunctioning devices. So for this case, if you do this self-diagnosis on the on the each and every component of the IoT system at the different layer, then my system will be the we can say it is a anywhere, anytime available IoT solution. So this kind of the requirement is required when you go for like IoT solutions. Can you go to the next slide? Hello? Yeah, thank you.
This one?
Now, if you look at the, yeah.
Hello?
Yeah, this one.
Hello?
Hi,
Hello?
this one.
This one?
Hi, am I audible? Yeah. Am I
Audible.
audible to all of you?
You are audible.
Yeah, yes. Okay. Now, if you just see, this is a 1 meter.
Hello?
Yeah, 1 minute. Now, if you just see this is how the IoT deployment framework to make the integrate the different kind of the IoT applications. So here, if you just see the edge node 1, end node 1, and S is represented the sensors. So in this case, different IoT solution. Suppose if I take the agricultural point of view, so this one red box is represented the one farms, different and different red box. Second red box will represent the second farms, and at the same way, the next third red box will represent the agricultural farm of the different areas. Okay, so in this case, we have the smart agricultural system that connect the number of the farm which is located at the different location of the state or maybe the city. So in this case, how this can be connected. So in this case, you can see different protocol between the end node 1 and edge node 1. The BLE. At the same way, in the second red box, it is a Zigbee is the communication. Z-Wave is the protocol in the third red box. Thread is the another protocol is used. Here, the access technology between the sensor and the edge node are different. In the same way, the edge node, that is the edge computing, is connected with the gateway. Gateway is the one kind of the fog computing, where we have to consider to in this case also the communication between the gateway and the edge node are different for the different provider, because the all this solution are providing by the different vendors or different designers. So this kind of the thing is the case here. Now, in the same way, gateway is connected with the cloud rate. There is one of the it is between the cloud computing and between the fog computing, there is another layer of the cloud rate. So this is also the one kind of the similar kind of the cloud computing platform that can be useful to reduce the latency between the actions. There is another kind of the requirement. It is a mobile edge node, which is directly connected to the cloud rate of the different locations. So here, in the same way, there is a connection between the two gateways with the use of the Wi-Fi, LoRa, and the Sigfox. So this kind of the application applications with the mobile application or maybe the sensor. And this will cover also if you see some of the edge node is directly connected to the cloud computing. Some of the edge node is directly connected to the cloud RAID. So depending upon the IoT application requirement, depending upon the type of the requirement, whether it is the long distance, whether it is a medium distance or large distance, depending upon the latency, minimum latency or maximum latency, more latency or less latency, depending upon the power consumption and based on devices. All this object are connected into the different layer of the edge computing, fog computing, cloud RAID, and the cloud computing. So this is one of the scenario where we need to design the IoT solution to cover the maximum different kind of the smart application and integrate this application to give the maximum efficiencies as a point of view of the customer and the and to utilize the resources very efficient. So that kind of the deployment framework, it is a need of the to make the your IoT solution or IoT system efficient. So in this case, it is not necessary. This is the fixed framework, but the different application of the depending upon the bandwidth requirement, or maybe I can say the requirement of the resource to make the cost effective solution for the any point of view in the bigger aspect. This can be designed in the manufacturing sector, or in the case of the smart cities. So different kind of the smart application are integrated. So this is the need of the making the IoT applications. Can you go to the next slide? Yes, can you go to the next slide? No, you go to the next slide. I will discuss this one later. Yeah, slide number. Next slide. Next slide. Now, 1 minute. Yeah. So in this slide, this is the another Yeah, next. It is okay. Yeah, it is okay. Now, in this case, this is a multi-tier IoT architecture. Here you can see different side of the cell, different side of the capacity of your sensor. It may be a small cell, macro cell, end user equipment, or maybe it is a micro cell. So this small cell is example of the suppose in the automation where only few devices like the 5 to 10, and in the case of the macro cell, it is having the more than 1,000 devices are connected, and in the micro cell at the time it is in the range of the 100 cell. There is another kind of the femto cell where the few devices like 4 to 5 devices are connected in the femto cell. Now in the same way, there are the different kind of the communication between the to make the system on the internet. So there is the one core networks, back haul networks, and the front haul networks. At the same way, it is the peer-to-peer communication. So this edge server, centralized unit, and the edge server and the core network. So this is the all are interconnected with the different kind of the sensor, different kind of the devices, and the different kind of the air interface. So this is the one kind of the multi-tier IoT architectures. So it is the previous framework, how it can be making the in the simple way regarding the this multi-type IoT architecture defined. Can you give it to the next slide? Next slide, please. Yeah. Now we have discussed the different kind of the applications. Now, if you just see the challenges in the IoT challenge, so one of the challenge is the interoperabilities.
Please conclude in 10 minutes.
Second is the management, and the third is the quality of service. So if you just see in the physical layers, so there are the many devices, many sensors are from the different vendors, and the each vendor or any or the sensor or actuator are having their own mechanisms to make the suppose the one sensor in agriculture the home. So if you want to interconnected this sensor, so there is the one issue it is called it your because of the multi-vendor and multi-functioning object. So this kind of the one of the challenge is the IoT challenges. One of the challenge is the interoperabilities. At the same way, I also talk about the platform, network and semantic synthetics. In the platform, suppose if you just take about the Wi-Fi is the one of the communication protocol in the one solution, one IoT application. In the second, it is used to be some Zigbee protocol or Zigbee platform. So if you want to connect this two different platform in the large sense, at the time the how this protocol can be interference. The the communication frame, communication between communication in the Wi-Fi and communication in the Zigbee are different protocol, and it is defined in the different way. So how these two different platforms are work together and make the sustainable or 24 by 7 available IoT solution. So this is the one of the issues here. At the same way, the networks. Then we just get the idea in the previous slide. The different object or different devices are connected using the different topologies with the different wireless technologies, wired technologies. So how these different networks are connected. In the internet, this can be taken care by the TCP/IP protocol. But here we cannot use the TCP/IP in the full sense because we need we have the constraint in our devices, in the IoT devices, where we have to use the lightweight protocol to make the communication between the two different networks. At the same way, semantic and the syntactics. So now, if you just take the data, what do you call the sensor data, every sensor data having the different type of the data format, different kind of the different kind of the size of the data. So these are the issues in the whenever you take the how the data different size of the data, different format of the data, and the different way of the data is sense. So this is one of the issue in the large sense IoT deployment framework. In the same way, device management. Device management and the data management and self data. If you just see device interoperability, there is one of the issue in the routing protocols. So in the internet, we have this can be handled by the IP protocol. But in the IoT, we have to make the lightweight in routing protocol, and the different technology use the different routing protocol depending upon the number of the node and the number of the based on the communication range. At the same way, the platform may be the operating system, programming language, and the data structure. So every this is one of the ways. Some are making the based on the R programming, based on the Python, or maybe the based on the Java programming, or maybe some another programming. Okay, so in this case, how this can be when you make the integrate the different so this is so this is a different kind of the uh, uh, because of the variety of the devices, variety of the networks, variety of the platforms, and the synthetic data format. This is one of the issue. If you solve this issue in the large sense, your IoT applications, the 50% of the issue will be solved automatically. So 50% of the issues in the IoT system, the operative in terms of the device work platform and the data syntactical and the semantic, because the everyone uses their own way to connect the devices on the IoT platform to make the your to fulfill a specific application or specific sectors. If you integrate these things, then we require the we have to solve this challenges to make the to achieve the concept of the IoTs. That is anytime, anywhere, for any business or any um, uh, any device. Okay, so this can be one of the issue when you make the integrated various applications to one system. At the same way, another challenge is the management. So there are the device management, data management, and self diagnosis and the adoptions. So I already discussed the device management, where the if the any device will malfunction or any device will be the changed, or it may be the new device will be the added in the uh, 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 I can the replacement of the device. So how it can be managed, that can be seen is the in the device management, data management, and the self diagnosis. In the same way, um, can you go back to the yeah. This data management, because there are wide range of the data format, and how to store the data, how to retrieve the data, how to process the data. That can be because the everywhere they are having their own way to storing the data, retrieve the data. But when you integrate the system, at the time this is very difficult to handle. So one of the issue or one of the challenge is the data management, and the diagnosis and the absorption is the one of the issue in the case of the hello. And the second is your quality of service. Quality of the service. The quality of there is one noise from the someone. Am I audible?
Yes, sir, you are audible.
There is some noise from
Please,
someone.
please try to complete.
The second is
in
the quality of
15 minutes.
service. To hear the mobility, availability, reliability, and the scalability. Mobility is as I discussed, depending upon the communication range, some of the devices are mobile and some of the mobile devices are static. So how whenever we go from one cell to the another cell, how the handover can be possible, how the identification of the mobile devices. So this is one of the issue in the IoT. Yeah, yeah. So this is what. Okay, yeah. Availability and reliability and the scalability. So this is the to make the available system. This is the availability of this is one of the issues because of the we require the reliable communication available and the scalability and the privacy and security. So this privacy and security is one of the challenges regarding the 30 to 40% is regarding the privacy and the security of the data and the network. So many it, many kind of the attack are, are, are on the data and networks to get the information about the uh, uh, critical. Yeah, hello, hello.
Yes, sir.
Next slide, please.
Uh, Sir, try to complete in 15 minutes. Sir. Hello. Hello.
Yeah.
This one?
Yeah. Please go to the next. Yes, sir. Hello.
Yes. Continue.
Am I audible?
Yes, you are audible, but there is some disturbance in your voice.
Slide number 12, I think.
Okay, you continue, sir. Try to conclude.
It is not visible. Slide number 12, I think. It is slide number
17. This is 17 number slide. Hello.
slide number 12.
Hello.
Slide
Hello.
number 11, 12. Hello, yes.
Yes, sir. Hello.
Am I audible?
You are audible, but your voice is not clear.
Yes.
Any more technical problem?
In this case, different kind of attacks, specified physical attacks, network attacks, application attacks, and the software attacks, and authentication and the authorization attack. And this is the idea about the attack on the smart engine, smart light. This is can be used for the different kind of the attack is useful here. Can you go to the your next slide, please, sir?
This one? Hello? 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 Hello?
મારામાં અવાજ ચાલુ તારો અવાજ ચાલુ કર
અવાજ ચાલુ જ છે મારો.
મારામાં અવાજ ચાલુ હતો અત્યાર સુધી એટલા વખત
હલો? હલો?
હું છું અંદર કે નથી
હલો? હલો?
મારામાં બી પેલા નોટિફિકેશન આવ્યા કરે
હલો? હલો?
મને જોઈન કરી લીવ થઈ ગયેલું
ચાર કલાકના
Am I audible now? Hello.
You are audible.
Now, can you go because of the some error network issue? Can you give me go to the slide number 25?
Yes, 25.
Yeah.
Okay, this one. Okay.
Now this is a this is the last slide. This is regarding the how we can solve the IoT challenges that we have discussed just now. We have to go to the different kind of the devices, different kind of the edges and data storage and user interface with the help of the business analytics, deep learning and the big data, real-time data module and the communication mechanism and the protocol. So there will be the different kind of the issues or challenges can be solved using the big data, deep learning, and interconnected communication mechanism to connect the different kind of the services at the different level of the stack of the IoT protocol. And to solve the security mechanism, there are the many techniques is available. With the help of this one, we can solve the challenges regarding the security point of view. Go to the next slide, please. And these are my references that I have taken the making the discussion possible here. And if you have any question, please ask. Yeah, this is from the my end.
Any question?
Audience, please, any question? Then they can write in chat box. Hello.
And I am very sorry to because
And,
of the some issues regarding the network and some voice problem.
any question? Then they can write in chat box or raise your hand. Raise their hand. And participant may note that we will update your attendance tomorrow for today's sessions. On ATAL portal. Hello. So we will share tomorrow YouTube lecture, all session lectures on YouTube YouTube channel. And thank you for today's participation. Tomorrow we will meet again at 6 p.m. Please be present